Hello everyone and welcome back to Return. I'm your AI host Amy, and today we are going to explore a concept that is absolutely fundamental to all of science, technology and especially artificial intelligence. It is a simple yet powerful idea of independent and dependent variables. Have you ever wondered how researchers prove that a new drug actually works? Or how an AI like the one that suggests movies for you learns your taste? The secret lies in understanding cause and effect, and that starts with identifying what we can change and what we want to observe. That is the core of independent and dependent variables. So let us break it down. Imagine you are a gardener and you want to know the best way to grow big, juicy tomatoes. You have a hypothesis. The more sunlight the plants get, the bigger the tomatoes will be. To test this, you set up an experiment. In this experiment, the thing you decide to change is the amount of sunlight each plant receives. You might put some plants in full sun, some in partial shade, and some in mostly shaded area. The amount of sunlight is your independent variable. Think of independent as what you, the researcher, control independently. Now, what are you measuring? To see the effect of sunlight. You are measuring the size of tomatoes from each plant. The size of tomatoes is your dependent variable. Its outcome depends on the amount of sunlight the plant received. It is the effect you are looking for. So to put it simply, the independent variable is the cause and the dependent variable is the effect. The independent variable is what you manipulate and the dependent variable is what you measure. Now, why is this so important in research? Well, by systematically changing the independent variable and observing the dependent variable, we can establish a cause and effect relationship. But there is a catch. To be sure that the change in the independent variable is what is truly causing the change in the dependent variable, we have to keep everything else the same. These are called control variables. In our tomato experiment, if we give the sunny plant more water than the shady one, we would not know if the bigger tomatoes were because of the sun or the extra water. The amount of water would be a confounding variable, something that confuses our results. So, good research design is all about isolating the independent variable to see its true effect. This principle is the bedrock of the scientific method and is used across all STEM fields. In medicine, the independent variable could be the dosage of a new drug, and the dependent variable could be the patient's recovery time. In physics, the independent variable might be the angle of a ramp, and the dependent variable could be speed of a ball rolling down it. But what about the digital world? What about artificial intelligence? Well, it turns out that this concept is even more critical in AI and machine learning. In fact, the process of training an AI is essentially a massive automated experiment with independent and dependent variables. Let us take a common machine learning task, predicting the price of a house. What do you think the dependent variable is here? What are we trying to predict? It is the house price, of course. That's our target, our effect. And the independent variables? These are all the factors that might influence the price. In machine learning, we often call these features. So, for our house price predictor, the independent variables or features would be things like the size of the house in square feet, the number of bedrooms, the age of the house, and its location. When we train a machine learning model, we feed it a huge data sets of houses where we already know the features and the final sale price, that is the independent variables and the dependent variable. The model job is to learn the complex relationship between all those features, the independent variables, and the price, the dependent variable. It's trying to figure out how much each independent variable contributes to the final dependent variable. For instance, the model might learn that for every extra bedroom, an independent variable, the price, the dependent variable, increases by a certain amount on average, or that in a particular neighborhood, another independent variable sell for more. The intelligence of the AI is its ability to understand these intricate cause and effect relationships from the data. So, in supervised machine learning, which is a very common type of AI, the entire process is built on this foundation. The labeled data we use for training is simply a collection of dependent variables and their corresponding independent variables. The features. The goal of AI is to create a function that can take new, unseen independent variables and accurately predict the dependent variable. Let us make this even more concrete with a bit of Python code. We will use a very popular library called scikit-learn to build a simple model that predicts a value based on some input. Don't worry if you are not a coding expert, the focus here is on the concept. First, we need some data. Let us imagine we have a data on how many hours a student studies and the score they get on a test. Here, which is the independent and which is the dependent variable? Pause and think for a moment. If you said that the hours studied is the independent variable and the test score is the dependent variable, you are absolutely right. We are trying to see how the hours of study affects the test score. In our code, we will separate these into x for our independent variables and y for our dependent variable. Next, we will use a simple machine learning model called linear regression. Its job is to find the best straight line that fits our data, describing the relationship between our x and y. We will import it from scikit-learn and fit our model to the data. Fitting is just another word for training. Now that our model is trained and we can use it to make predictions, let us ask it, what score would a student get if they studied for 7 hours? We give it this new independent variable, 7 hours, and it will predict the dependent variable, the test score. And there you have it. Our model, by learning the relationship between the independent variable, or studied, and the dependent variable, test score, can now make educated guesses. This is the fundamental principle behind so many AI applications, from predicting stock prices to identifying diseases from medical scans. A common point of confusion is the difference between correlation and causation. Our model found a correlation. As study hours goes up, scores go up. But does that mean studying causes higher scores? In this case, it's very likely. But in more complex scenarios, two variables might be correlated without one causing the other. For example, ice cream sales and shark attacks are correlated. They both go up in the summer, but one does not cause the other. A third variable, the hot weather, causes both. That's why good research and AI development are so careful about experimental design and feature selection. We want to be as sure as possible that the independent variables we are using are truly the cause of the effects we are seeing in the dependent variable. It is about asking the right questions and being rigorous in how we seek the answers. So let us recap. The independent variable is what you change or control, the cause. The dependent variable is what you measure, the effect. In AI, independent variables are our features and the dependent variable is our target or label. Understanding this distinction is not just academic, it helps you think more critically about the world around you. When you see a news headline that says X causes Y, you can now ask, what was the independent variable? What was the dependent variable? And what were the control variables? It is a powerful tool for clear thinking. Thank you for joining me today on Return. I hope this has made the concepts of independent and dependent variables clear and shown you why they are so vital to scientific discovery and the future of AI. If you found this helpful, please give the video a like, subscribe to our channel Return, and let me know in the comments what topic you would like us to explore next. Until then, stay curious. Thanks for watching. See you in next.